Welcome to the CER Writing and Math. And again, your CER is your claim, your evidence, and your reasoning. So we're going to explore how we could do this in math. So here's a word problem. Tom and Bill went trick-or-treating last weekend, and they still have a lot of candy left. Together, they have 78 pieces of candy. Tom has 34 more pieces than Bill. How many pieces does each boy have? So using your claim evidence reasoning is just a way to formulate your writing, to make a claim, which will ultimately be your answer, to sort through all this math, all the numbers, all the facts that are given, and come up with your evidence. And your reasoning is really what ties your evidence back to your claim. And it basically justifies why the evidence fits the claim and the claim is correct. So, again, the first thing we want to do is we want to look at the evidence. You never write your claim first, whether it's for science or whether it's for math. So the evidence is the mathematical information and data that supports the claim. And the information and the data needs to be appropriate and sufficient to support your claim. So let's start working through your sheet. So in the define section, what you're going to need to have, and again, you've already written this in class and now we're just going over it, is Bill equals X. Tom equals X plus 34 because it said in said in words in the paragraph that Tom had 34 more pieces than Bill, but you still don't know what Bill has. And the other key piece of information is the sum of all candy equals 78. So if Bill is X and Tom has 34 more than X, what would you do for an equation? So this is what you would have in your define section. Now in the do section, I'm going to quick put up a screen here. So again, here you have Bill, here you have Tom, and here you have the sum of the candy. So this was the original. So basically you're setting up an LRE and you're working through this. So what's the very first thing you want to do? You want to CLT it or combine like terms. Well, there's an X here and an X here. The only reason I have this parenthesis in here is so that you know this was Bill, this was Tom. So if there's nothing in front of the parentheses, it's a 1. So 1 times X is X, 1 times 34 is 34. So you can basically just drop the parentheses. So when you CLT it, there's 2 X's and there's 34. So now we have to isolate that X. To do that, you have to move the 34 out or get rid of it. So the inverse of adding 34 is subtracting 34. So you subtract 34 from both sides. So now you have 2X equals 44. So here it's 2 times X. What's the inverse of multiplying by 2? You should have dividing by 2. So once you do that, you get X equals 22. So now we know what X is. So let's go back. So Bill was X, so X is 22 years. Now Tom was X plus 34. So if you take 22 plus 34, it equals 56. Now I want to check to make sure my math is correct. So then I'm going to add 22, which is Bill. I'm going to add 56, which is Tom, and it should equal 78. And once I do the check, I figure out, yes, it is indeed correct. So now you have your define, do, and decide. This is your evidence that you need. So the last thing you need to do is fill in your reasoning. But you might be thinking, wait, we haven't written a claim yet. Well, based on this information here, you can write your claim. So we actually have to do 2 things yet. We have to write our claim. Remember, claim is a conclusion that answers the question and should be a complete sentence. So here's my claim. And remember, the original question was, how many pieces does each boy have? Bill has 22 pieces of candy and Tom has 56 pieces of candy. Now this is much better than just simply answering it, well, 22 and 56. Or Bill has 22, Tom has 56. 22 and 56 what? Pieces of candy. So this is a full, complete sentence, and this is what I would expect from you. So we have our claim, we have our evidence. Now we have to use our reasoning, which is a justification that links the claim and evidence. And it shows why the work counts as evidence by using appropriate and sufficient mathematical principles. Now when I looked at a lot of your examples of what you wrote, what you did was, some of you did a really good job. You've got most of what you needed. You just missed a few parts. Some of you just had a very general, this is what we did, this is how we came up with the answer, and you finished it in a couple sentences. This should be a solid paragraph. So I'm going to read you what I wrote. Says it said in the problem that Tom and Bill each went trick-or-treating and that together they have 78 pieces of candy. Tom has 34 more pieces of candy than Bill. I used X as the variable for the amount of candy that Bill has. Tom has 34 more pieces of candy than Bill, so I used the expression X plus 34 to represent the amount of candy that Tom has. Knowing that if I add together Bill's and Tom's candy, I get a total of 78 pieces. I set up the equation X plus 34 equals 78 to find the value of X. So in this one I didn't have the parentheses, but you can see that I basically summarized the entire problem right here, and I explained how I came up with the equation. So I'm looking for an explanation that walks me through, and again, you're trying to walk me through because I'm the one who's grading your work. You're trying to walk me through each step. How did you do step A? How did you do step B? In other words, how did you do the first part of it? How did you do the define? How did you do the do? How did you do the decide? And so you're going to have to walk me through each step. So all this was just basically going through the initial paragraph and going through the define part. How did I get the equation? So how did I solve the equation? Well, so solve this problem for X. Should probably say to solve this problem for X, so I'll have to fix that. To solve this problem for X, I first combined like terms to simplify the equation of 2X plus 34 equals 78. I then subtracted 34 from both sides to get 2x equals 44. I then divided both sides by 2 to get x equals 22. This means that Bill has 22 pieces of candy. Tom has 34 more pieces than Bill, so I can add 34 to 22 and get 56, which is the number of pieces of candy that Tom has. Bill has 22 pieces of candy and Tom has 56 pieces of candy. I can check my answer by adding these two numbers together. The total is 78, which matches the total from the original problem. I can also check my answer by substituting in 22 for x in my original equation. When I do this, I also get 78. So in this slide right here, I went through and I basically told you how Bill was 22 and how Tom had 34 more pieces than Bill, so 34 plus 22 is 56. So I basically went through the rest of the do, and then I did the decide section. Notice that this part right here, Bill has 22 pieces of candy and Tom has 56 pieces of candy, is also my claim, because you should have your claim in your reasoning. And I have this concluding statement basically saying how I checked my work to make sure that it was correct. And that's the neat thing. You can always check your work to make sure it's correct. One of the most common problems I had with these CERs was right here. Some of you had the wrong equation. Some of you simply said 22 plus a number equals 78, and you took 78 minus 22 and you got a completely different number. However, you could have done it that way, but make sure you set up the equation. Some of you simply subtracted some numbers to get some other numbers, and you didn't really get the numbers that you were supposed to. Notice that Tom had 34 more pieces than Bill. So think about this for a second. What were your final numbers? If you add your final two numbers together, does it equal 78? And then did Bill have a number and then Tom have 34 more than Bill? Because some of you had really high numbers that were much, much greater than 34. So again, check your work, and it's always important to go through, like I did here, check to make sure it's correct, and right here, write how you check to make sure that it was correct, because you should always be checking your numbers. So go through this, fix any mistakes you had, look at the problem, so the next time you have this, it may be for a grade in the grade book, you know how to do this, because you're not going to be able to use the guide like I let you use the last time, where I let you use your interactive notebook to take a look at this. So again, as always, make sure you ask questions if you have any in class.